we have to do this video, because it's part of the course. For some reason, as you can probably tell, I don't like Sankey diagrams. I think they're so stupid. Like, please, I mean, if you agree with me, put it in the comments. Like, just I don't like them. They're so stupid. What's the point? It's like, this is the energy that is useful. This is the energy that is wasted. You can literally just read it off of the. You can say, this is how much you need. This is how much is wasted. I don't understand why we have to put them in a diagram, which has to be to scale with the width and the curly arrows. That I just don't get it. Sort of a rant rather than an educational video at this point. I think they're stupid, but you need to know about them, you need to know what they are, you need to know how to draw them, and they're worth an absurd number of marks as well when you have to draw them from scratch. Here's a tutorial video to help you do that. Okay, let's see if we can use our knowledge to answer this question, okay, about Sankey diagrams. So, Sankey diagrams are just a way of representing energy input, okay, and energy output in terms of energy that's useful and energy that isn't, okay? So when we're drawing a Sankey diagram, what we have is effectively our input, okay? And then what we have is our useful energy, okay, like this. And then we also have a bit that comes down like this, which is our wasted energy. Okay, I haven't done that great, right? But this is the kind of basic view of a Sankey diagram, okay? And there's a few rules that we sort of have to remember when we're drawing Sankey diagrams, okay? And that is that the arrow that continues straight on is always our useful energy output, okay? Always our useful energy. The arrow that droops down to the side, okay, that is our wasted energy, okay? That's our wasted energy output. And then this bit is our total input. Okay, that's always the case, right? Another thing that we need to consider is the scale, okay? And I'm doing this in capital letters because it's really flipping important, okay? It's really, really, really important that you get this bit right, okay? So when I say scale, what do I mean? Well, I mean that the amount of energy that's wasted and the amount that is useful needs to be represented as a ratio of the total input, okay? So an example might be if you had lined paper, you know, 1 square on your lined paper is going to be equal to 10 joules, right? And if your input was 100 joules, then you would have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you get the gist, right? You need to have a scale, okay, when you're doing your Sankey diagrams. Okay, so let's say that 1 centimeter is equal to 100 joules, and let's say that this is my 10 centimeters. I know that it's not completely accurate, but let's say that that's 100 joules and that's equal to 10 centimeters. Now, if we look at this question where my efficiency is 75%, that means that 75% is going to be useful energy. Okay, if it's 75% efficient, that means that 75% is useful energy. Okay, so 75% of my line, okay, 75% of this needs to be useful energy, right? So when I draw the line, okay, it needs to be 7.5 centimeters long, like this, okay, roughly this. Okay, and then the rest is going to be my wasted energy, right? And the most important thing is actually the width. Okay, it's actually the width here. I've done that quite badly, right? But for my scale, if 75 joules is useful, yeah, that means that 25 joules is wasted. If my scale is 1 centimeter to 10 joules, because 10 joules is 10 centimeters, then this has to be 7.5 centimeters in width. Okay, and this has to be, you guessed it, 2.5 centimeters in width. Now it's really the width, okay, that is the most important thing with Sankey diagrams. The length of the arrow is not actually that important. It can go on forever. It's going to be irrelevant. What you need to do
when you're doing your Sankey diagrams is, one, you need to use a ruler, and two, you need to make sure that you've got an appropriate scale, okay? Because otherwise you're going to misrepresent the amount of energy that is being partitioned in this given situation.
Okay, so hopefully that was helpful and you now understand how to draw these things to scale and, you know, label them and stuff. Please like and subscribe. It's very, very helpful. It helps us get more quantum content to you guys. But in the meantime, I'll see you next time with a less negative video. Bye!